Good morning. Welcome to your Lab 2 dosage calculations. This group should include Brittany, Steins, Ebony, Stephanie, Widener, Candace, and Ariel. This section will go through from 8:45 to 10:15, and then you'll take a break at 10:30. As we move along, you'll have moments that I'll prompt you to pause and then restart when you're ready to work on your own and then check your answers. So the first set that I want to go through are nasogastric tube feedings. So this is going to be your workbooks from pages 27 to 30. You can pause here for a moment while you find these the pages. So the first set of problems I want to show you how to use is the nasogastric tube feeding problems. These are going to be when we are using a nasogastric or PEG tube, which is percutaneous entry into the gastric system for feeding. So these are feeding going into the stomach, not through the IV. Now often these will be already ordered telling you how much water to calculate, to add in order to dilute this. However, we need to also know how to calculate these ourselves. So we have a modified formula that I want you to use. So we're going to find X. X is going to be our total. And we're going to find that by taking our can of feed over our numerator. And then we're going to times it by the denominator of the concentration. And then this is going to equal our total. But when the question asks for water, we need to take our X minus the can to get our water. So, for example, number 1 on your workbooks, we have a 3/4 strength of tube feeding for the patient. The formula comes in cans of 240 milliliters. How much water will the nurse add to the can of formula to make the order 3/4 strength diluted tube feeding? So plugging it into this formula first. So we have our can is 240 milliliters of our can over our numerator, which is the top number, and our denominator, which is the bottom number, so down, D for down, denominator, times 4. And you're going to get 80 times 4, which is 360 milliliters. But this is our total. Remember, this is X. So the question is not asking our total to be infused, but how much water do we need to dilute it? So then we're going to need to take our total minus our can, remember up here, 360 minus 240, and we're going to get 120 milliliters of water. So this is our answer. Water, water. Okay, you can pause here if you need another moment to follow through and make sure that you're setting this up correctly with this modified formula. So moving on to number 2, we're going to set it up the same way. So we have our can is 233 Remember to use all of as many units as possible so that you know what you're left with when you're done. And that is not all water, this is can. Since we have multiple milliliters for units that we're using in the same problem, adding the can and the water will help you know that what milliliters you have at the end. So our numerator is 1 times our 3, and we're going to get x, and then we're going to subtract by 233 again to get our milliliters of water. So 233 times 3, using my calculator, is 699. Minus 233 again is going to be 466 of water. And make sure, yep, this is asking for the total of water. Okay, you can pause here and work on number 3, and then you can verify your answer when you come back. Okay, so number 3, we're going to set up like this. 237 is our can, over 2 times 3, and that's going to be x, 237 divided by 2, and then times 3 is 355.5 minus 233, and we're going to get 122.5 milliliters of water. So our answer is 122.5 milliliters. Now we're going to add to this concentration of tube feeding so that we can administer it through the right concentration per the order. Number 4, you can pause here, work on number 4, and then check your answer. So number 4, we're going to set it with 250. Over 1 times 4. So that's 100 milliliters, 1,000 milliliters. Oh, I keep pressing my little button. Minus 250 equals 750 milliliters of water. So we're going to add 750 milliliters of water to this can. So our total that we're going to have is going to be 1,000 milliliters. However, at this time, the physician only wants 200 milliliters to be infused every 6 hours. So make sure that you're using the can to get your total, to get your water. That's what the question is asking. So this order, because it's being given intermittently instead of full continuously, you need to pay attention to what the question is asking. So you did not need that 200 milliliters for this type of question. If it was a question on how long would it take for this to infuse, then you would need your total, 1,000. That's going 200 milliliters every 6 hours. And then, so then 1,000 divided 200 every 6 hours. So 5 times 6, it would take 30 hours to infuse. So, but it's not that type of question. So make sure, again, you're paying attention to what the question is asking you, that you're using all of your units of your can versus your water. so that you know what you're left with, and paying attention to that this is your total, not your water. So if the question is asking you for your water, you are not done. If the question is asking you for your total, then you are done here. You stop. All right, you can pause here and work on number 5 and then check your answer when you're done again. So number 5, our can is 237. Numerator is 1 times 2. 237 times 2 is 474. This is our X, and the question, is asking for water. So minus 237 is going to give us our milliliters of water, which is half of what it is, so it's the same thing, 237. So remember, also on your exams where you have your little box, and then it's going to have your units on the side. So pay attention to the units to let you know if you are using, looking for your total for your water, just to verify what you have and what the question is asking for based on the units for in the box. Okay, for this next section, I want to introduce to you your infusion rates and working with flow rate. So you can pause here while you find these page numbers in your workbooks. This should be all in one grouping PDF that I had uploaded in your Canvas. So it flows, it's all one workbook, but it should go through pages 85 to 89. So, working with infusion rates, we're going to see how many milliliters per hour that the infusion is going to be given, or with flow rate, how many drops per minute. So this first section of your workbook for this area is going to be how many milliliters per hour. So what you're going to take is your total. So you desire to infuse your entire amount, the amount to be infused, and what you have now is time. And our okay, so we have 1,000 milliliters to do number 1. And then we have 12 hours to infuse it. And what we're going to get is 83.3. And our units, nothing crosses out, so it's milliliters per hour, which is what the question is asking. So again, always do that double check. 83.3 milliliters. Okay. So you can pause here and look at your answers when you come back. Okay, so for number 2, you have 1,000. 16 hours. It's going to be 62.5. Number 3, you have 3,000 over 24 hours. You get 125 milliliters an hour. Number 4, you have 250 over 1.5 hours. You get 375. Number 5, you don't need the 1 gram. we're only talking about amount of fluid, so milliliters. So we have 50 milliliters and it's going to infuse over 30 minutes, so 0.5 hours. 50 divided by 0.5 is going to give you 100 milliliters an hour. So this is the rate that it's going to be infused, and once it's done, we're going to wait 12 hours and then do it again, but it's being infused over this time. Okay, so pay attention to the question there again. Number 6 is 1,000 over 6 hours, and you get 166.7 milliliters an hour. Okay, so here we're going to modify our formula again for flow rate. This is when we're doing our drops per milliliter for a drop factor. So our desire is going to be the amount again. So this should be in milliliters. But this time our have is in time, but it has to be in minutes. This is where sometimes we have accidents with your stress on the exams, where the previous infusion rates, milliliters per hour, here, when you plug this in, it has to be in minutes. Because when we do our drop factor, we're going to times our drop factor, which is going to be in drops, which our abbreviation is GTT per milliliter. And what's going to happen is we're going to cross out our milliliters and we're going to be left with drops per minute. This is the unit that we will need in our answer. So remember looking at your box and the units that's mentioned there for drops per minute to make sure that you are using minutes. So number 1, we're going to set up as this. So we have our amount here is 1,000. And then we have 1,000 milliliters. Our have, we have 8 hours. So we're going to need to convert this to minutes. And then our drop factor is here. So 1,000 milliliters. 8 hours, so 8 times 60 minutes is going to be 480 milliliters times 60 drops per milliliter. Oops, this is supposed to be minutes. And what we're going to get is 1,000 divided by 480 times 60. We get 125, and this is drops per minute. You can pause here, try to work it out, make sure you understand it before you move on to number 2. So with number 2, we have again 1,000 milliliters to be infused. We don't know our time frame yet. We're going to have to work that one out. And then our drop factor, my light went off. There we go. 15 drops per milliliter. So you'll do what we did in the first section of 1,000 milliliters. That's going at 83 milliliters per hour to get hours. So we're working this one backwards. So 1,000 divided by 83 gets me about 12 hours. But remember, we need minutes. So 722.9 minutes. Now, so if you use the 1,000, you have to use the full amount. You have to use the full amount of time. However, it already gives you what you're doing. So another way to do this is use this here. So we have 83 milliliters in 1 hour, which is 60 minutes times the 15. Okay. So you can do either or. This one is already given to you, so to me it's the easiest and simplest way. Less math, shortest amount of time to also to do it. So then what we get, 83 divided by 60 times 15, we're going to get rounding to 21 drops per minute. So when we're calculating drops per minute, what we're meaning is literally counting how many drops are going to be infused within a minute. So this is usually, we can do this without a pump, or there's specialized tubings that will make sure that there are this many drops that will be infused in this many minutes, and also infusing through the pump. But a good rule of thumb, if you're not using a pump and something tells you how to do it milliliters per hour, you can convert it to minutes and count it. This is what we had to do in crisis situations, such as when we were in New York City. So you would stand there and count drops. Obviously, staring at something, drop, counting it, doing an entire minute, and then having to adjust because it's wrong, and then count, and then adjust, and adjust, and adjust, and adjust can be quite time consuming. So what you can do is divide by 4. So then you're counting how many drops are in 15 seconds, and then would be equivalent to times 4 for a minute. So that you are making sure that you're infusing the right amount of medication at the right rate that is appropriate for the medication, so it doesn't cause any problems, and that you are following the order, but you do not have a pump. Now there are certain medications that you have to use a pump. You will not eyeball this, and certain things like that are going to be like potassium, vancomycin, and then like blood pressure medications like dopamine, big critical medications like that. But other than that, most other medications, if you don't have a pump, because of crisis situations, you can determine your rate by counting drops per minute. So you can pause here and work on the next couple of questions. And so number 3 and 4 I have on this next section. You can pause and then check your answer when you get back. So for number 3, we're going to have 500 milliliters. 4 hours is 240 minutes times 10 drops per milliliter. 500 divided by 240 times 10, and we get 21. So the reason that mostly we're going to be rounding to the nearest whole numbers, because you can't count half of a drop when you can't see half of a drop. Only a drop drops at a time. So usually the closest whole number. Number 4 is going to be 30 milliliters over 60 minutes, because it's already given to you in the easiest form, and 15 drops per milliliter. And we're going to get 0.5 times 15. Is 7.5. There you go. Now you can pause here and get to your direct IV medication administration, so pages 90 through 93. So with direct IV medication administration, this is going to be like IV push. But we're going to need to make sure that we are pushing it at an appropriate rate per the drug reference. So the drug reference will give you maybe a range, maybe a maximum, but we need to make sure that we're giving it within that recommended dose per the reference, right? So for number 1, we are to administer 10 milligrams IV push stat of morphine, and the reference says that for direct IV, which is what we're doing, and it's the same drug, morphine, it's a high alert medication, so we are to administer 2.5 milligrams to 15 milligrams over 5 minutes. So it's asking, what is the rate of administration for this dose? This is going to be a direct question. It gives us a range. Our order is inside that range, right? 10 is between 2.5 and 15. So it's telling us anything between this range, 5 minutes. So then we're going to IV push this slowly over 5 minutes. That's the answer. Whereas, look at number 2. Our order is 3 milligrams hydromorphone. It wants it to be administered slowly at a rate not to exceed 2 milligrams over 3 to 5 minutes. Rapid infusion may lead to increased respiratory depression, hypotension, and circulatory collapse. So don't infuse this fast. So then it's asking, therefore, what is going to be the rate of administration for this dose? Now, first, is 3 exceeding 2 milligrams? Yes. So we need more than 3 to 5 minutes. However, that 1 milligram that is left, we can't infuse it faster than this recommendation. So you need 2 whole sets. You need 2 milligrams over the 3 to 5 minutes, and you need the whole another 3 to 5 minutes again for the last milligram. So all the way to 2. So you need a whole set. If you can't divide this set, if you divide this set, technically what you're saying is that that last milligram, you're infusing faster than the recommendation. You can't do that because of this. Okay, so you have to take the whole set. So how many sets of 3 to 5 minutes do I need? I need 2 sets. So then 2 times 3, and then 2 times 5. So I'm going to infuse this between 6 and 10 minutes. That's how you do those type of problems. You can't separate the set. So then pause here and try to do number 3 on your own, and then come back to check your answer. So for number 3, we have 80 milligrams to infuse now at, and this is direct IV. So we're going to use direct IV here. We're not going to do this one. So it says to administer at a rate of 20 milligrams per 1 minute. 80 is how many sets of this. So 80 divided by 20 is going to give us 4. So we need 4 sets of 1 minute. So it's going to take us 4 minutes to infuse. Okay? You won't have many of those problems, but you need to understand how to use the entire sets and not portions of them. So again, you can pause here to find your next set of calculations for pediatrics and safe dosaging for these page ranges. So for pediatric calculations, for this first section, it's going to be similar, just what we've already done with our desire over half times vehicle for your medications to administer to a child, because this is going to be on oral routes. So desire have vehicle. So you have your 0.25 grams for your order. You have available 125 milligrams, and they are in tablets. So how many tablets are going to give? So 250 milligrams is our desire. What we have is 125 in tablets, and it's going to give us 2 tablets. And then our number 2, you have our order for 350 milligrams every 12 hours. And our suspension is 125 milligrams in 5 milliliters. And it's asking per dose. So this is where, especially in the next section for our appropriate dose ranges, you need to make sure that what you're given is what it's asking for. So per dose versus per day. So per dose, where order is per dose, so we don't have any conversions to do. We can just move along. So 350 divided by 125 times 5 milliliters is going to give us 14 milliliters for our dose. Okay. So you can do the rest of these problems on your own, but we're going to move on to determining safe dose for the sake of time. So safe dose, we're going to be giving medications based on body weight, so we need to use their kilograms. We also need to therefore know our conversion from pounds to kilograms. There are 2.2 pounds in 1 kilogram, okay? So our kilos should be a smaller number than our pounds. So what we're going to do is make sure that this is an appropriate dose for them, as well as safe. So on many of these, we have an A, B, and a C. So B for these are asking for safe. Safe means that it is less than the max. Okay, so as long as it's less than the max, it's going to be safe for the child to take. It's not going to harm them. However, I want you to add a part C for, is it therapeutic or appropriate? Okay, so on all of these, just go ahead and get in the habit and add a C on all of these, therapeutic or appropriate. So that means it has to be within the range. So you need to know a minimum and a maximum. So it needs to be greater than the minimum and less than the maximum. So within that range. So first, let's start with A. We have 200 milligrams every 12 hours for a child who weighs 30 kilos. The recommended dose for this child is going to be 7 milligrams per kilogram every 12 hours. So these are the same, so I'm good. So I'm going to move on. So I have 20 milligrams, 200 milligrams, I don't know why I said 20. Is our order. So what we're going to do is look at this. So 7 milligrams per kilogram, and we have a child who is 30 kilograms. So 7 times 30 is 210 milligrams. So what is the maximum safe dose, which is using this, for this child? This child is 30 kilos, so they should get 210 milligrams. This is the maximum. So is the ordered dose safe? Is the order less than 210. Yes. So this is a safe dose. However, for C, is it therapeutic or appropriate? So it needs to be greater than a minimum. We don't have a minimum in this question, so it's unknown at this time. You can't assume, because what if the minimum was 205? It needs to be between 205 and 210 for this child. Well, then 200 is below the recommended minimum of 205, and therefore it would not be therapeutic. But we don't have a minimum, that's hypothetical. So right now, it is unknown. So number 2, they are 8 kilos. It says 30 to 50 mics per kilo. The question is asking maximum. So for A, I only need the maximum, which is this number. So 50 mics per kilo times our child of 8 kilos is going to be 400 micrograms for our maximum. This is what the question has asked. So pay attention on your exams if it's asking for a minimum, a maximum, or a range, or if it's a safe dose versus a therapeutic dose. Okay, so for B, is the ordered dose safe? Now we look at our order. Our order is 250 micrograms. Is that safe? Is it below 400 mics? Yes. So it is a safe dose. However, for C, add your C, remember. Is it appropriate or therapeutic? So now we need to do our minimum. 30 mics per kilo, or 8 kilos kid, and we're gonna get 240 micrograms. So it needs to be between 240 and 400. Is 250 between 240 and 400? Yes. So it is also a therapeutic dose for this child. Now go ahead and move on to number 3. Remember to add your C for therapeutic, and pause here so that you can confirm your answers when you return. So 66 pounds divided by 2.2 is going to give us 30 kilos, is our first thing that we need to know. We have a single dose for 2 milligrams dose, and then we have a 6 milligrams for a day. It wants to know our maximum, so we need to do this one. So our maximum, 6 milligrams per kilogram, and our child is 30 kilos, is going to be 180 milligrams, is our maximum dose. Is the ordered dose safe? 40 per day. The maximum is 180 per day. So yes, it is safe. Is it therapeutic though? So our minimum is 2. And we get 60. And 40 is less than 60. So it is not enough to be appropriate for this child. So we need at least 60 milligrams for this child at this weight to have the desired effect of this medication. So this is not appropriate amount for him. It is safe, it's not going to harm him or her, but it is not going to do its required and ordered therapeutic effect. So number 4, pause here and then come back to check your answer again. So 77 divided by 2.2 is going to give us 35 kilograms. Our recommended dose for children less than 50 kilos, which we are, is going to be 0.3 milligrams per kilogram every 3 to 4 hours. This is also the same as here, so I'm not going to worry about that one. So then what is the maximum safe dose based on this literature? So we're going to take 0.3 milligrams per kilogram. We have a child that is 35 kilograms. 0.3 times 35 is going to give us 10.5 milligrams every 3 hours. It's the ordered dose safe. $20 milligrams is less than 10.5? No. So this is not safe. And therefore, if it's over the maximum, then of course the therapeutic is also going to be no. Even though we didn't know the minimum, we know it's over the maximum, so it's not appropriate. So, number 5. You can pause here if you want. So we have 6 to 7 milligrams per kilogram every 24 hours in 2 to 3 divided doses. What is the safe dose range? So once the whole thing range, so minimum and the maximum for this child, which is 55 kilograms. So let's do 6 milligrams per kilogram to 7 milligrams per kilogram, 55. And we get our minimum of 330 and our maximum of 385. But this is every 24 hours. It wants it to divide it in every 2 to 3 doses. And so to compare our per dose, because it's saying dose, not daily range, dose range, every 8 hours. So there's 24 hours in a day. If we're giving it every 8 hours, we're going to give it 3 doses in a day. So let's do the 3 and not worry about the 2. So if we're going to divide this by 3 doses to get our minimum and maximum per dose. So 330 divided by 3 is 110. And 385 divided by 3 is 128.3 milligrams. So this is per dose. And we have now what the question is asking for per dose range. So the ordered dose safe is 125 in that range. Yes, it is. Or at least, is it less than the maximum? Yeah, so then C for therapeutic is in the range. And so yes, it is. So you can do the rest on your own time and at home. Move along to your infusion and completion time for your workbook pages for 94 to 98. Infusion and completion time, I just want to go over a few things on this quickly. You'll do this at another station as well. So again, we're going to need to know milliliters per hour. So some questions like number 1 will give you your milliliters per hour. If it doesn't, you need to find that first. So if we have 1,000 milliliters going at 125 milliliters an hour, what is the infusion time? So how long is it going to take to infuse? It's going to take 8 hours. If it doesn't tell you in your thing for round 2, make sure that you have your hour versus minutes, and make sure that you're looking at your box for what your units are as well on your exam. All right, so for number 2 and 3, you can pause here and try to do them on your own, and then come back for checking your answers. So for number 2, we have 500 milliliters infusing at 60 milliliters per hour, and that's going to give us that shouldn't be that. There we go. 8. Come on. I'm trying to make an 8 out of that. Let me just erase that. There we go. 8.33 hours. Infusion time. How much time is it going to take to infuse? Remember to look at your box for your units to know what I'm asking for. It'll be a little more clearly written in these workbooks. So for number 3, we have 1,000 milliliters going at 75 milliliters an hour. And we're going to get 13.33 hours. Technically, you didn't need that drop factor unless you wanted to do it with the drop factor instead of the milliliters per hour, but then you're going to have to convert to hours because that's going to be a lot of minutes. So for this next section, starting on page 96, similar to what we just did with finding out how much time it's going to take to infuse, now we need to add it to what time it started. Okay, so for number 1, we have 1,000 milliliters infusing over 10 hours, and she started at 9. At 10 o'clock, patient pulls out the IV and restarts the IV at 11 o'clock at the same rate. Using the amount the IV fluid left at 1100, calculate the new infusion time and completion time of the IV. So first, what we need to do is 1,000 milliliters going over 10 hours is going to be what rate? It's going to go over 100 milliliters an hour. So if it started at 9 and it's at 10 o'clock, 100 milliliters should be infused by 10. Okay, but from 10 to 11, nothing was infused because the IV infiltrated. But then from 11, it was restarted. So then it's going at 100 milliliters an hour again. So if it's going to take 10 hours, we're going to count this hour, but we're not going to count this hour, right? So 1 would be 11, and then here. So 10 hours, so 1 hour, 2 hours, 3. This is 4. This is 5. This is 6, 7, 8, 9, 10. So it should end about 8 p.m., which is going to be 2000. Infusion time is going to take, like we said, the 10 hours. So from 9 to 10 was 1 hour. We're not counting this one. 11 to 12 is 2 hours. 3 hours, 4 hours, 5 hours, 6 hours, 7, 8, 9, 10. So it's going to end at 2000 because we're skipping this one. So for number 2, let's see, we're infusing 500 milliliters of our 75 milliliters an hour, and she started it at 1330. 2 hours later, she increases it to 100 milliliters an hour per the doctor's order, and if she had fluid remaining, what would be the new infusion time? So first we need to calculate, so these from here to here is 2 hours, so 75 milliliters an hour times 2 hours is going to be 150 milliliters is going to be infused out of the 500. So from the 500, we still have, what, 350 to be infused. But now she's increased it to 100 milliliters an hour. And it's going to take 3.5 hours from this time. So infusion time is going to be this time times plus this time, so 3.5 hours plus the 2 hours initially. It's going to give us 5.5 hours to infuse, and it's going to then therefore complete 3.5 hours after this. So 1530 plus 3.5 hours is going to be, this is going to be a 6, so that's an extra hour. 8, 9, 1900. It's going to finish at 1900. Okay, so you have until about 10:15 for this area, and then you can take a break till 10:30. Once you're come back from your break at 10:30, report to the side of the lab that Miss Love is in. If you have time remaining, you can continue to work on your workbooks.